My name is Tristan Killer, and my research paper is on quantum computers and the differences they have on conventional computers, as well as what kinds of benefits quantum computing may offer. The title is Quantum Computers Will Change the World. This may seem like an overly ambitious title, but I do assure you that quantum computers could change the world right now if they were available. All the way back in 1837, someone by the name of Charles Babbage actually invented something that was very similar to a computer. It was called an analytical engine, and it inputted Boolean data and works very similarly to how conventional computer nowadays works. Now, people have been working on computers for a very long time, and they've come a long ways from single inputs like something that was made a couple hundred years ago. However, recently, people have actually started to develop and work on quantum computers. Now, quantum computers work similar to how a conventional computer would work in how they are given a problem and work in a state in order to develop a solution. However, there are some really big differences with quantum computing. I think the most important way to understand quantum computing is to understand the differences in how they organize data and how they send and receive data. In your traditional conventional computer, you're going to have an input, and the computer is going to process that input in what we call binary. And that basically just means that a bunch of bits inside the computer will either be turned on or off. They have a high or low state, 0 and 1. And that means that these computers, which work with regular physical properties, can only ever be either on or off. The special thing about quantum computing is that it actually changes all of that. You are now able to do things like have any in-between state. You can have both states at the same time, which is actually called superposition. And this allows for a lot more data transfer than ever before. There's also another property of quantum computing called entanglement. And before, for all of computer history, we have tried to isolate the individual bits so they don't interact with each other, because then it can interrupt electrical signals and things like that. But with quantum computing, entanglement actually means that the bits will work together. And so each qubit, which is a bit inside of a quantum computer, or a quantum bit, will actually be able to interact with the qubits around it. And this means that they can actually work together to come to a solution to the problem that they're working on. So now we have the ability to not only completely control the state of which the qubit is in, we are now able to have them work together. So out of all the possibilities we could have had before for different types of states for the bits, we now have all of the in-between states, and they can work together. This dramatically increases productivity with any type of computing project. It doesn't matter what it is. Something like cybersecurity, where you make a really complex password so that way someone tries to hack your account, they won't be able to get into it because of your password. Well, what you can do is you can use a computer to generate an algorithm that can eventually come out with a solution that is your password, and they can get into your account. But something like that would take a very, very long time, because it's basically up to random to provide that solution. But with something like quantum computing, they can try different solutions at multiple times, and they can arrive to these solutions much quicker. And it allows for something that could take a decade to solve a conventional computer. It could take, hours to days, or maybe even a week with a quantum computer. In my research paper, I used the black hole that was photographed this year in April. It had about 5 petabytes of data that was taken from all of the telescopes across the globe, part of the EHT system. All of that data generated, 5 petabytes is a lot of information. It's about 1 million gigabytes, and something like that took them about 2 years to process with conventional computers. But again, if they had access to quantum computing, something like that could only take a matter of months. So as you can see, productivity is increased greatly. You have this machine now that is capable of doing things exponentially better than what we already thought was exponentially better. So you have this improvement off of improvement, and it's just only putting humans to shame, really. The conventional computer was already better at computing than a human 1 million times. The human can only process about 5 to 7 bits of information at a time, whereas a quantum computer might be able to handle, millions or billions and even maybe trillions of bits at the same time.